Homework number 5. The first 2 lessons are based on equations that have special solutions. Let's take a look at what those 3 solutions are. When solving an equation, you can have one solution, that's where your variable is equal to a number. You can have no solutions, where there are no numbers that would make the statement true. Or you could have infinite solutions, where any number would make the equation true. Any equation that has just one variable term always has one solution. Let me give you an example of what I mean. I could have something like this. There is a variable term here, and there are no other variable terms. So therefore, after our properties of equality and solving and isolating x, there would be one answer. And sometimes sentences have more than one variable term, like something like this. And as long as those variable terms have different coefficients, then you know that you will have a solution. Now sometimes your sentence might have a same variable term on both the left side and the right side, like this. Both of these variable terms have coefficients of 3. Now, if the constants that come after those variable terms are different, say something like this, then that means that there would be no solutions. There's not a single number that we could substitute in for x that would make the statement true. And sometimes, when you have the same variables on both sides of the equation, and their coefficients are a perfect match, and their constants are a perfect match, then we get something known as infinite solutions. That's where the left and right side are a perfect match. So let's take a look at a few questions. This first question asks us when we will have one solution for our equation. And if we refer back to this chart that you may need to copy down, in order to have one solution, you have to have different variable terms. It doesn't matter what the constants are. Any constants will work. Same constants, different constants, doesn't matter. But the variable terms must be different. So if this left side has a variable term of 9x, this right side cannot. So h can be any number, but not a 9. So I'm going to type a random number in this box here. I typed a 6 because you get one solution when you have a different number of x's on either side, and you can have constants that are the same or different, doesn't matter. Let's take a look at one more. This one, again, wants us to have one solution. So remember, when you have one solution, your coefficients of x have to be different. So you can choose any number you want, but not a 2. So I'm going to put a 7 in here, and that means I have different number of x's, and the constants can be the same or different. This question asks when we will have 0 solutions. That's another word for no solutions at all. And when we have no solutions, we have to have the same variable terms, but different constants. So let's take a look at what we have. We have a variable term on the left that's a 10x, and they want to know what we need on the right. And when we have 0 solutions, our number of x's have to be the same. So that means h has to be a 10, because the constants are different. So same variable term, but different constants means no solution. In this question, we're asked to find an equation that has infinitely many solutions. And infinitely many solutions have a perfect match on the left and right sides, same variable terms, and the same constants. So if I have a 2x on the left and a 2x on the right, then I'm set up for a special solution. And if the constants are the same, a +1 on the left and a +1 on the right, then I would have infinitely many solutions. Because when you have infinitely many solutions, you have the same number of x's and the same constant. Let's take a look at the next section. The next section is the same concept, but the questions up here might require a little bit more thought. So we want to have 0 solutions. Remember, 0 solutions means we have matching variable terms. So if I have a negative 7x on the left, I need a negative 7x on the right. So if I distributed this h to that x, what would I need? I'd need a 7, because you have to have the same number of x's and different constants. This one asks us to have one solution. Now when you have one solution, that means your variable terms are different. So this multiplying number here in the h position, this distributing value, has to be a number such that I don't get a negative 12. So I can put any number I want here in the h position, but not the number 4. So I'm going to pick a random number, 7, because I need different number of x's, and the constants can be anything, same or different. So in this topic, look carefully at what you're distributing so that you can get the right amount of solutions. Infinitely many solutions have matching variable terms. So I need a 2 in the h position so that I can get the same number of x's and the same constants. All right, the next section asks you to solve some equations and decide how many solutions there will be. So you're going to need some scrap paper for this section. Once I distribute on the left-hand side, I get 4x minus 8, and when I distribute on the right side, I get 5x minus 20. Now the left and the right side each only have one variable term, and they are different. So we know already that we are going to have one solution. We already know we're going to have one solution. So when I go back and click one solution, it's going to ask me what the solution is. So now all I have to do is finish solving this equation. So I'm going to subtract 4x from both sides and rewrite. And then I'm going to add 20 on both sides and rewrite. And the answer is 12. So I'm going to enter that into this box and we'll be done. So for this one here, when you distribute, you're going to get negative 16x plus 24. And on this side, you're going to get negative 21x minus 3. So I can tell already that I am going to have one solution. And once I finish computing all that math, I can determine what that one solution will be. So let's take a look what we're going to get here. 5x plus 24 is equal to negative 3. 5x is equal to negative 27. Divide by 5, and I can get negative 27 fifths. I think you could convert it to a decimal too. So let's see. Let's try entering it as negative 27 fifths, see what we get. That's it. All right. The next question asks you to continue to solve some variable equations. So you're going to distribute when you have parentheses. So here on the right-hand side, I'm going to distribute this negative 6, and then I'm going to stop. So 8x is equal to 12x plus 24 plus 8. Now you notice on the right-hand side I have 3 terms, and the most you should ever have are 2, a variable term and a constant term. So if you have more than one constant term, you can do a combination move, right, where we combine these like terms. And I compute directly what I see. So I have positive 24 plus 8. So when I rewrite this, I'm going to get 8x equals 12x plus 32. Now I'm going to subtract 12x on both sides to get my x's on the same side of the equation. And then I'm going to divide by my coefficient of negative 4, and I get my final answer, which is negative 8. Type that in your answer box, and you're all set. Again, practice distributing the coefficients outside of the parentheses, even if it's just a minus sign. So it does have a coefficient. Technically, that's a 1 there, so it's a negative 1 times everything inside. Make sure you watch your signs, and rewrite anything that's after the parentheses. On the right-hand side, I'm going to distribute that negative sign again. Now my left-hand side has 2 constants, so I'm going to combine them together, giving me negative 3x minus 2 and negative 7x plus 9. I'm going to add 7x to both sides That gives me 4x minus 2 equals 9. I'm going to add 2 to both sides. That gives me 4x equals 11. And I'll divide both sides by 4. And I'm going to leave my answer in fraction form. I'm not going to convert it to a decimal. I'm just going to leave it as is. 11/4. So type that in and submit. Alright, the next section contains equations with decimal. Alright, let's take a look at this question here. For this problem, you'll want to use a calculator, and you can use your own handheld calculator, or you can use this online calculator linked in the Google Classroom. So let's take a look at the left-hand side here. We have a 10x, and then we have a plus 5, which is touching parentheses. So that means we need to distribute this 5 before we do anything with this 10x. So I'm going to rewrite that 10x, and then I'm going to multiply 5 times negative 3x, and then I'm going to multiply 5 times 4.5. So let's see, 5 times 4.5 is 22.5. So we're going to put 22.5 here. Then I'm going to recopy everything else in the equation. Now my left-hand side is pretty long. I have 2 variable terms and I have 2 constant terms. So I'm going to combine these terms together by using the operation that I see in between them. So I've got 10x's minus 15x's, which will give me negative 5x. And I have 22.5 plus 0.9. So 22.5 plus 0.9. 23.4. So plus 23.4 equals 7 plus 5x. Now I'm going to subtract 5x from both sides so that I can get all of my x's together. That leaves me with negative 10x plus 23.4 equals 7. Subtract 23.4 from both sides. And get negative 10x equals 7 minus 23.4. And I get negative 16.4. I'm going to divide both sides by negative 10, and that's going to give me 1.64. So I'll type that in here. And that's it. So all of these problems just have some parentheses in them, and you'll need to be distributing any coefficients that are outside. And be careful, like this one here. See this negative 9.4? That is not what's being distributed. It's this negative sign that's being distributed. And anytime you have a negative sign all by itself, there really is this invisible coefficient of 1 there. I'm going to multiply negative 1 times each of those items. And then you can continue to solve. Let's take a look at the next topic, which is fractional linear coefficients. And since you have a calculator, this shouldn't be an issue for you because you're going to use the same technique. You're going to distribute this fraction, a coefficient outside here to each of these terms inside. And so you're going to use your calculator to type 7/6 times 4, right? You can use this fraction button. 7/6 times 4, and then you can type that 14/3, and then 7/6 times 18. So when I get that here, this 16 over here on the left will remain. So 16, and then I believe we got 14/3, and then 7/6 times 18 is 21. You're going to subtract 21 from both sides, giving us negative 5 equals 14/3 x. And here's where it gets a little tricky. You have a couple of options. When I have a fractional coefficient, I choose to multiply both sides by the reciprocal, like this, instead of dividing by a fraction. So I'm going to get 3/14 times negative 5. So 3/14 times -5, and I get -15/14. And that's how I'm going to write my answer, -15/14, just like that. All right, so when you're distributing your fraction, you can use your calculator to assist. And then if you have a fractional coefficient, when you get to your final step, like we would here, right? 13 is equal to 1/2 x minus 3, and we'd be adding 3 on both sides. So 16 is equal to 1/2 x. I'm going to multiply both sides by 2/1. Because that is what you do when you have a fractional coefficient. You type your answer. For us, we'll type 32, and we're done. All right. For these last two sections here, we're going to talk about some different type of equations, these absolute value equations. Absolute value equations are answers that have equations that have two possible solutions. So that's why you have this button here for additional solution or no solution. Okay? So when you have an absolute value equation, such as this one, you have to start by getting rid of any math that is outside of the absolute value bar. So if there was a coefficient here, or if there were constants here, you would remove them first. And once they're gone, then you set your problem up twice. Because absolute values says what numbers are, so for this one here, what numbers are this distance from 0? So what numbers are 3 units from 0? And the answer is 3 or -3. So all you need to do for an absolute value equation is do the problem twice. So we're going to remove the absolute value bars because we've answered the question. What numbers are 3 units from 0? And the answers are 3 and -3. So now that we've answered the absolute value question, we can write what's inside the absolute value bars on each of these two separate problems. And we'll solve them each separately. So I'm going to subtract 2 on this side. I'm also going to, whoops, I made a typo over here. 2 minus 3y. And I'm going to subtract 2 over here, giving me -3y equals -5 in this problem. But on this side, I get -3y equals 1. So when I'm dividing here, I'm going to get 5/3. And when I'm dividing over here, I'm going to get -1/3. So I have two solutions, -1/3 and 5/3. So -1/3, add a solution, 5/3. And those are the two separate answers. So every time you start an absolute value question, you're going to start by answering the absolute value first. What numbers are 11 units from 0? The answers are 11 and -11. Now nothing else will change. You will simply copy the quantity that's inside the parentheses on the left side of each of these equations. And you will solve them both separately, and those two answers are your solutions. So add 4, add 4, add 4, add 4, but for each problem, you could get a different result. So when I add 4 on both sides, on the first equation, I get a 15, but on the second equation, I get a -7. So 15, add a solution, -7. All right, let's take a look at the next topic. Consecutive integer problems. Consecutive integer problems can be a little bit tricky, and that's because you don't know the numbers, so I'll call the first one n, but I do know that the next one after it mathematically is going to be one more. And the one after that is going to be 1 more than that. And the one after that is going to be 1 more than that, right? So sometimes we simplify these to n plus 1, n plus 2, n plus 3, etc., etc., etc. This is the options of translations for consecutive integers. But the problem we have here says that Ava is the oldest of 4 siblings who are consecutive odd integers. And when you have consecutive odd integers, you skip count. So instead of going 1 digit like this, right? If I'm 1, the next odd integer is 3. So I have to skip twice. So if your first integer is unknown, the next integer is going to be 2 more. And then the next integer is going to be 4 more. And the next integer after that is going to be 6 more. And I know it says odd, but the pattern is always even because we skip by 2s. So Ava is the oldest of 4 siblings whose ages are consecutive odd integers. This is the first sibling, this is the second sibling, this is the third, and this is the fourth. So now we have our translation guide. These are the only items that we can use. And now, these are the hints of how to write the equation. The sum of all their ages is 104. So the sum of all their ages would be the first plus the second plus the third plus the fourth is equal to 104. And now I can simplify this left-hand side. I've got 1, 2, 3, 4 n's. And I've got 2 plus 4 is 6, plus another 6 is 12. And now I can solve this equation here by doing some simple properties of equality. Let's see. 104, 10 minus 10 is 94, minus 2 is 92. Divide both sides by 4. That's, the first one is 23. Now it says Ava is the oldest. And 23 is this one. So 23 is the youngest. So then the next one would be 25, 27, and 29. So Ava is 29. All right, let's try another problem. The sum of 3 consecutive even integers. So far I know I have 3. I know they're consecutive even, and I have the answer. So again, our options are, the first one is always n. And if you are consecutive even, that means you're going by 2s, right? You're skip counting. So the next one would be n plus 2, and the one after that would be n plus 4. So these are our only options since we have 3 integers. It says that we're going to find their sum. So the first one plus the second one plus the third one has to be equal to negative 24. So simplify the left-hand side. Solve for n. And now we want to find the value of the greatest of the 3. Well, n is the smallest. So if this one is negative 10, then this one will be negative 8, because negative 10 plus 2 is negative 8. And then this one will be negative 6. Let's take a look at the last one. The last topic says, Henry is younger than Cameron. Their ages are consecutive odd integers. So remember, consecutive odd integers start at n and skip count by 2. Henry is younger than Cameron. So that must mean this is Henry, and that must mean this is Cameron. Find Henry's age if the sum of Henry's age and 2 times Cameron's age is 85. So I'm going to add Henry's age and 2 times Cameron's age to get the sum of 85. And Cameron's age is n plus 2. So now I have my algebra equation. I'm going to distribute my 2 I'm going to combine like terms on the left-hand side. I'm going to subtract 4 from both sides. I'm going to divide by 3 on both sides. And now I know how old Henry is, because Henry is this one. Now I see on Delta Math they use x instead of n, but it doesn't matter what variable you use. Let's take a look at the next question. It says the perimeter of a rectangle is 260 feet. Find the length and width if the length is an even integer, so the length is an even integer, and the width is 5 times the next consecutive even integer. Now remember, when you have consecutive even integers, your first one is always x or n, and the next one is always skip counted by 2. Okay, so this one would be the first integer, and then this one would be the next consecutive integer. And since they say that we don't know the length, then we're going to say this is the length. And we know that the next one, the width, is 5 times as much as this, right? 5 times that. Now typically, we put that 5 in front, like this. And now, we also know the perimeter. So far we have all of this information. The length is some random integer that we don't know. We know it's even, okay? And we know that the width is 5 times as much as the next one. So now we have to start thinking of how do you find the perimeter of a rectangle? So we don't know the length, but we know the width is 5 times the next integer. So we could fill in this drawing here to kind of help us visualize what's going on. And there's a couple of ways we can find the perimeter. We could literally add up all 4 of the sides. Put n plus 5 parentheses n plus 2 plus n plus 5 parentheses n plus 2. We could add them all up and say they're equal to 260. Or we can use the perimeter formula. And the perimeter formula is when you write p equals 2 times the length plus 2 times the width. So it's really up to you how you want to set up your problem. So the long way would be add up side number 1 with side number 2 plus side number 3 plus side number 4. This would be correct. This would be one way to set it up. And the other way to set it up would be to fill in the number for perimeter, which is 260, and then instead of writing both of the lengths out, you put a 2 in front of how much the length is. And you put a 2 in front of how much the width is. And the length is n, and the width is 5 times n plus 2. So either one of these green sentences would be correct. I'll use the bottom one here, the formula one, since I have space underneath it. And I'm going to start by distributing this and distributing that, but not distributing him yet. So my next step will be 260 is equal to 2n plus 2 times whatever this blue and red work is. 5 times n plus 10. Now I can distribute this too. So the perimeter is equal to 2n plus 10n plus 20. So now I'm going to keep going, and I'm going to get 260 is equal to 12n plus 20. I'm going to subtract 20 from both sides. So let's see, subtract 20 from both sides. I'm going to get 240 is equal to 12n. Divide both sides by 12, and that's going to leave me with 20. So n is 20. Scroll all the way back up. And what is n again? The length. So the length is 20. But the width is 5 times 20 plus 2. So 5 times 22. So now all we have to do is type the length is 20 and the width is 110. Oh, that's what we said, right? 20 and 110. And we'll submit. Let's take a look at one more. Okay, the perimeter of a rectangle is 166 meters. Find the length and the width if the length is an odd integer and the width is 4 times the next consecutive odd integer. Now remember, it doesn't matter if it says even or odd. Anytime you are even or odd, you are still skip counting by 2. You are always skip counting by 2. So it doesn't matter whether it says even or odd. The translation is always the same. We don't know the first one, but we know the next one will be plus 2. Okay? So for this problem, the perimeter is 166, and it looks like the length is an unknown odd integer, so the length is some unknown, and the width is 4 times the next one, which would be n plus 2. Just like the last problem, I'm going to use the perimeter formula with the parentheses as a shortcut. So the perimeter is 166, the length is n, and the width is 4 parentheses n plus 2. There's double parentheses down here, so I'm going to do the inside first, giving me 166 equals 2n plus 2 times 4n plus 8. Then the next set of parentheses, and that gives me 166 equals 2n plus 8n plus 16. Combine like terms, 10n plus 16 minus 16 on both sides. 150 is equal to 10n. Divide 10 on both sides and get that the first odd integer is 15. So if the length is 15, then that means that the width is 4 times 15 plus 2, or 4 times 17. All right, so we've got 15 for the length and 4 times 17 for the width, which is 68. So we've got 15 and 68. And that's it. Last one. Evan is younger than Kadeem. So we've got Evan and we've got Kadeem. And their ages are consecutive odd integers. So we don't know who Evan is, but he's younger. And Kadeem is the next odd integer after him. So we skip count by 2. Find Evan's age if the sum, so we're going to add these two things together, the sum of Evan's age, that's n, and 2 times Kadeem's age, so that's 2 times Kadeem, is 73. Distribute. Combine like terms. Subtract 4 on both sides. Divide both sides by 3. And now we know how old Evan is. Good luck.